All right, you there, Jody?
I think I figured it out.
All right.
Can you hear me?
Yes.
Okay. Okay, Brian figured it out.
Oh, good.
I was using a mouse.
And that was the problem?
Apparently.
Yep, sound good now.
Okay, well,
Oh, good.
let's roll. All right.
Okay.
Phenomenon. Middle school breakout room.
So session 2. So I'm Anya Covarrubias.
I'm Jody Barr.
Okay.
All right. So our question today is about what makes a phenomenon academically productive. Earlier, you guys had an opportunity to chat, and some of the things you guys said was that it needs to be something that's relevant, engages students, helps students use phenomenon to figure out science ideas.
Right, and so in order for us to figure this out, those were all like really great ideas that were in the chats. But what we're really going to be talking about today is analyzing the standard in order to know which phenomena is going to work best.
When you're selecting the phenomenon, it really needs to be relevant to the student and makes the student wonder, which is awesome because it sounded like when we asked that beginning question, the majority of people really had a good understanding of that. All right, so the big question is why analyze standards? The first one is they are complex and they're super packed in terms of different components of 3 dimensions. So that's one of them. Also, just the opportunity for a teacher to make sense of what the standard is asking. And then by making sense of it, it kind of helps you generate what phenomena you want to have.
Absolutely. Okay, so here we're gonna talk about what bundle we picked. So we are middle school physical science, and we are looking at emotion and stability, forces and interaction bundle. And we asked last time that people go in and like brainstorm some ideas for phenomena. And we had tides, egg drop, space pods docking with space stations, and seasons. And so this is the 2 standards that we're really going to get to know in order to pick our academically productive phenomena.
All right, so what you see here is there's lots of different ways of unwrapping standards. Anya and I had a great conversation about this because Anya, more or less, up until just about a week ago, was doing this just kind of on scratch paper. But yet then once she discovered this template, it definitely cleaned up her way of thinking, as well as it probably makes it a little bit easier for her to be able to send that off to another teacher. The key with looking at unwrapping standards is to focus on all three dimensions, which is kind of what this template allows you to do. It's just kind of organize your thoughts.
Right, so this right here that you're seeing is from the evidence of learning statement page. So if you were on NGSS, you could click on this. And we're going to be not only looking at the PE here, but also science and engineering practice, disciplinary core idea, and a cross-cutting concept. So this is our the actual template here that we're going to be using. And we're going to click into one that Jody and I worked on last week. All right, so here I did make some highlighting just to kind of make it easier for you guys to see what we did. But we copied all this in from that evidence of learning statement on NGSS. For us Nebraska teachers, we could also use our teachers' guides to get this information. But this was all just copying, pasting, so pretty easy at the beginning here. Do you want to talk us through this first little bit here, Jody?
What I liked about the way Anya approached this was she color coordinated it. So you could so when you unwrap the skill, you're looking for the verb. When you're unwrapping the concept, you're looking for the noun. And what I liked about it is if you go back up to the top, you can see how she color coordinated that as well, so that you can see specifically where she's pulling this information from. So that was something that I did another one of these separately, and I was not color coordinating them, and felt like the colors helped me make the connections between this entire process.
Right, and another thing that's really, once I started doing it, at first I was pulling down some like random nouns and verbs, and then I tried to start making them make sense a little bit as you kind of read across, and that helped a lot. So in that PE and that SEP, it talks a lot about planning and investigation, right? Both of them, that's what the students are doing because it's the science and engineering process or practice. And so plan and investigation, and then I really wanted to get some more details here, and I was able to find that in this planning or the SEP column here. So it talked about multiple variables, and it even gives me some more details down here that I use for that design solutions piece. And so now the students are planning an investigation to answer questions and test solutions with multiple variables, which wasn't actually initially something that you would have read in that PE if you wouldn't have unwrapped it. So the next one is provide evidence to support explanations. And the last one was this design solutions. This definitely was not in the PE. And so if you weren't unwrapping this, you would never uncover that these standards want them to design solutions to identify independent and dependent variables and controls and the tools needed. And so this really gave me so much information about what the students were supposed to be doing. It was very helpful.
Yeah.
And this was the one that we had the participants do. And then we kind of highlighted these. We had quite a bit of information in the chat. And again, a lot of them were correct. And because there are lots of nouns and verbs, but it's like I think the key is really trying to, make sense of it across those three rows so that you can use this information for not only picking a phenomena, but also for learning targets and also for assessment. All of that would be very useful. So for the cross-cutting concept, we had explain and examine stability and change for change over time, and then construct design systems for forces at different scales. And so, I mean, that cross-cutting concept adds a whole nother layer to how students should be thinking during this standard that really isn't explicit in that original PE. All right, do you want to talk them through the performance conditions?
The one that I really liked is that it does not include trigonometry.
Yeah.
So that's also one of those, I feel like that looking at the general performance conditions also kind of helps you decide on how far you need to go into it. I don't know, are we going to talk about, there's another way that you can kind of go back and look at what they should have already gained and then what they, yeah.
Right, so for this, you definitely want to look at that clarification statement and the assessment boundary. But our Sarah Cooper, she typically does not like to call this a clarification statement because the PE doesn't need clarification if they're clear. So just really getting at what this PE is wanting you to teach. And then the next step after you kind of have that goal is getting into that DCI and the framework and really the meat that the content bit. So we know how the students are going to be thinking and we know what the students are going to be doing, but we don't want to just open up the textbook to where it talks about mass of an object and gravity, because there's so many extra vocabulary and so many extra content pieces that textbooks put in so that more people buy them. And really the best place for us to figure out what we need to teach kids is in the framework that we'll show you in 1 minute. And then in this middle column of this DCI right here. And so that's where we got this information. So I just tried to read through this and I just tried to chunk it and pare it down and put it almost like in a student-friendly language so I knew exactly what I wanted them to figure out here. So this first one was motion of an object is determined by the sum of the forces acting on it. And then it says, you know, like what real world phenomena can students use this information to explain, or what, you know, if you start getting some ideas here. So I put like the Rube Goldberg, you know, because that might be something I could use. And I don't know if that's going to be my phenomena, but it might be like a little lesson phenomena that I use to get them engaged for that day, or I might not use it at all. But I'm kind of starting to brainstorm some of those ideas that I have as I'm looking at the content. Did you think that was helpful, Jody, this box here?
Yeah, actually, that I was just about to say, like, honestly and truthfully, for individuals that may have not been actively involved in writing the standards or still very, you know, like I'm starting to work with elementary teachers with the standards, but yet I'm not terribly familiar with the elementary standards. So unwrapping them and doing this part where it's kind of like breaking all of those, that entire paragraph and breaking it down. I don't know, for me, it just makes it a little bit easier, a little bit more clear as to what the expectation is.
Right. Right. And I guess that framework is also going to tell us like where they are supposed to be at the end with this content and where they ended from the previous time that they learned this standard, or this topic rather. And so the framework is really going to be a really useful, and let's just go there.
Yeah.
So this is just the physical science framework. So there it comes in pieces. So if you just get online, if you are on NGSS, that automatically will click you into it. If you are on the evidence of learning statement, which is really, really handy. So this is our motion and stability, forces and interaction. And so it's just these couple of paragraphs that really pare down the information just from here to there. That's what they want students to know. That's it. And then here's where they're going to have had the standard before. So they had it in 2nd grade, the end of 5th grade, and then they have it again in 8th grade. And then they'll have it again in high school, obviously. And so if we are, this is where we need to get them this is where they were prior to that, and this is where they'll start in high school. So this is just such a useful document that everybody needs to be using.
I use that document just today. I have a fellow staff member, and she's working on some grad classes, and she was kind of asking about, curriculum and where first grade should be versus third grade. And I was like, well, here you go. And I just showed her that, and I also showed what Nebraska was doing, and she's like, wow, this makes it so much more clear. So.
Yeah, absolutely. I know for us at Grand Island, we don't have a resource for our integrated. And so like literally that framework has been like my Bible. Otherwise, I wouldn't know where to even go. We don't even have a textbook right now. So.
Well, and I'm thinking about a lot of teachers that are the only science teachers in their buildings. And so sometimes for me, I alternate between physics and chemistry every other year. So it's very difficult for me to get super familiar with the standards, because then the next year I'm focused on physics, and the following year. So I really use that a ton in preparation for whichever class I'm teaching that year.
Right, and it's not a whole chapter of reading; it's 2, 3 paragraphs.
Yes, and same with if you have multiple preps, that's what I love about it as well.
Yeah. So the next piece, these two, this is kind of more brainstorming, and that's what I used to call my little scratch paper, was like my brainstorming, like what other SCPs could I use, what other cross-cutting concepts, what other what phenomena did I have ideas about, where were the connections, and so this is where I get to think about my standard and say, okay, if they're looking at the motion of objects and the sum of forces and the greater mass of the object, a model would be really useful for student understanding. Also, if they were constructing explanations, because up here, when I was unwrapping, they were supposed to construct to support explanation. So they're providing evidence to support an explanation. So I know that they need to, at some point, gather some evidence and write an explanation over it. So I went ahead and put those there. And then I also thought cause and effect might be a good one. There's probably some more that just naturally fit, and you kind of want to list those here. Here we kind of cheated. We went to the Wonder of Science website. Wonder of Science, if you haven't seen it before, is Bozeman Science, which I think everybody has probably heard of his videos, but he's put together this really neat website that has all the different standards, and you're able to just scroll down, and he has different phenomena, that ideas. He has anchoring charts made by teachers. He has his videos, not only for the DCI, but the SCP, and then he has his vocabulary here. And this is where we pulled this vocabulary from. And then it says not to put the definition, but the reason your students need to know this. And so Jody went through and wrote these out just because, if you're teaching in a teacher team, or if you switch content and another teacher comes in, we can look up the definition easy, but needing to know why they need to know that is more important. And then for this one, our focus was to write some learning targets here. These also could be assessment kind of questions. So I tried to sum mine up into 2 learning targets that I would use in class. You could definitely do a lot more learning targets and kind of choose from them, but I was thinking of it very practically, and like what 2 would get my kids to this standard. And so I did these, and I made sure that they were written 3D, just because that really has helped my classroom this year, making sure that every lesson was 3D, writing a 3D learning target, because the students know what they're doing and how they're thinking and what the content is. And then it really helps me stay focused and make sure I'm doing all 3 of those things every day. All right, Jody, do you have anything to add about the unwrapping document? Whoa.
No, I mean, it really does make you, I feel like, we were talking about phenomenon specifically, but eventually, we're going to talk about storylines and, all the pieces of a really good three-dimensional unit. And it really, I feel like, starts with unwrapping because it
Yeah,
gives you a better understanding of where we're going.
right. So I just kind of had talked about the framework here. And so this is really kind of just taking us through one last level here. And the person that we use kind of as our model in figuring out this academically productive phenomena, they took that unwrapping document and then put it into some different categories to kind of help us really be explicit about the type of phenomena that we wanted and predict some student explanations so that we would know what evidence we wanted from the phenomena in order for it to show us if it would be academically productive. So you can't just look at a phenomenon and say, oh, that one looks flashy, that one looks good, that one will be interesting. You really kind of have to dig into that phenomena and then compare it back to the bundle, and that's what we're going to show you now. So go ahead.
Did you discuss the predict student explanation, why it's on the last slide, the X?
I didn't read it explicitly, but why don't you talk about that?
Yeah, because that was the part that I struggled with, and Anya had to help me with that piece. And it's and it goes back to what our kids are writing as well. A lot of times kids will answer a question with it is, rather than starting with this explains this. We are trying to explain how two objects collide. I think of it almost as restating the question into a sentence. So I felt like that was really important part for me. And I've noticed that I'm trying to do that a little bit more in class when students even ask me a question. If I'm going to answer it, I'm going to try to restate the question just so that we start practicing
All right. Absolutely. So this is our last part here. So from that unwrapping document, we kind of just put down for each standard, the facets and the prior knowledge, just the real meat of what that performance expectation is. And again, we got this from that DCI column and from that framework and from the SEPs and the cross-cutting concepts that we pulled out the verbs and the nouns from. And now we can really have a really clear picture about what this is asking from us. And now it's time to find our phenomena.
Yeah.
All right. So I just went to Wonder of Science and I picked these two. These were both, they're both great phenomena. And now we just need to see if they will fit our bundle and they will be academically productive. And when we say academically productive, what we're saying is that the students will ask questions that will lead us to the direction of that standard. So you can give them something engaging, but if it's causing them to go down this path over here, away from your standard, that's not going to be academically productive. And so we want the students to ask questions and we want them to feel like they are in the driver's seat. We want them to be in the driver's seat. That's why we have to pick phenomena that will, when they ask questions, we can anticipate that those questions are going to go right along with what we need out of that standard.
So we've got two phenomena. We got Felix and Cavendish. And the big question would be initially is just which one would you think would be more intriguing to your students and more engaging? I know with Anya and I had this conversation where I was like, oh, Felix, definitely, because Felix, I'm a space junkie and that stuff is what interests me. Not to mention I looked at the length of the two videos and I was like, oh, Felix for sure. But once again, it goes back to what is academically productive for your bundle. So,
all right, so let's check this out. So So this is the student explanation that we were talking about. Again, I cheated and I got this off of The Wonder of Science. They have little descriptions written. So if you asked your student, what is this phenomena about? And they were to write it, this would be something in the direction that we would want them to go for both of our different phenomena here. So this one is really looking at Newton's second law of motion, where this is really looking at forces between two objects. And so let's see how it matches our standards. All right, so this is our claims for the interactions of two objects. So if we look over here for Felix, what do we think? Is this a match or not? And we didn't have a lot of time in our original recording. But I think that people would have probably said it isn't a great match, or maybe we would have had some, oh, could work, maybe. But when we really take a look at our second one here, and you look at what the Henry Cavendish phenomena is talking about, it really links up with what our claims are expecting. And so this one is actually a better match in order to get our students thinking. Now, I also like to think about, I know the video for the Henry Cavendish was 15 minutes long and extremely boring, so we might not show the video, right? We might, as teachers, watch it and then just get students jazzed up, get the bowling balls out and start modeling it ourselves. Mm-hmm. Also, this one has some crazy comments under the YouTube video from flat earthers. And so I thought that was something interesting. Maybe you could just go over the comments on the videos and talk about that. Like, okay, so if the earth was flat, how would this change the information that we're talking about? And maybe we could get them to think about the gravity between two objects if earth was flat and how that would orbit. And, who knows? Lots of different ways to engage, but I think this phenomena is more academically productive because it's going to have students ask questions that go down what that bundle is wanting from us. Anything else you'd like to add here?
Not really. I mean, other than honestly, Anya and I definitely were at each other trying to get this figured out, and it wasn't until we finally finished unwrapping the standard, or the standard, that we were like, wow, okay, now we understand. Because I think, I know I was totally for the other phenomena initially for multiple reasons, Felix. But then once I was able to break that down and look at it, I realized, which one would get me to where my students need to be.
Right. Yeah, and it was really fun doing it with another teacher and being able to, talk. And if you teach by yourself and you're kind of on an island, I was thinking of this later, like if you could talk to the high school teacher or the 5th grade teacher or the 2nd grade teacher that also teaches this topic, and you guys could break these standards down together and then kind of really see that progression and talk about what phenomena you'd want to use in 2nd, 5th, 8th, and 9th. That would be really cool if you didn't have a teacher team that you were teaching this with.
Yeah, I didn't even think about that. But that would be a great way to also have a better understanding of what's going on at the elementary level, if you're high school, or vice versa.
Right. All right. So I hope that was helpful.
Okay, so we should leave this meeting so that we can put this. I'll ask. I don't know where the recording went. I think Scott will have to put it up for us.
Okay. I made sure the office wasn't on.
Yeah.
All right. Have a good night.
Thanks. Bye.
See ya.
See ya.